I'm Jun Nakajima from Intel. In this section, actually, I had too much wine yesterday, last night, so I had some headache. Now, I think it's kind of clear now, but anyway. So I'm going to talk about moving a backend from DOM0 to HBM domain, and talking about the performance, mostly performance gain and scalability things, and also optimization issue, comparing EPT page flipping versus copying. Okay, so there we go thing. So notice this picture in architecture has backend driver on HBM side, and DOM0 doesn't have backend at this point. Oftentimes we hear some complaints about scalability issue, I/O scalability issues of Zen, because sometimes the distributors have a UP DOM0 or even PB DOM0 are not so scalable as you have a more BCPUs. And as you know, we're going to have a bigger machines with multi cores, right? Number of cores per socket is increasing today. Okay, so scalability, especially I/O scalability, is kind of issue, and the motivation here is to offload some I/O workload from DOM0 to HBM. And there are some other benefits of doing that. By using HBM, you can actually use existing Linux distribution. And it's important because some device drivers are certified. So it's better if you can use a certified device drivers. And as I presented at the last Zen Summit in Shanghai, on the recent machines, actually HBM outperforms PB for many cases. There are reasons, right? Because of the nature of per virtualized MMU support, that it's not chaos fault, right? This is the nature of per virtualized MMU. So with HAP, EPT, or nested virtualization enabled, you get better scalability, especially when you have a SMP guest, right? And with direct I/O, now the cost of virtualization is much lighter now, okay? And with this, by moving I/O capability from DOM0 to other domain, okay, then essentially we can restart that domain upon I/O failure. Of course, we need to do some recovery things because of the front ends need to reestablish the connection, right? So there are other things, but there are some possibility of restartable I/O capability. The other thing is, once we have this kind of infrastructure, we can have a multiple instance of HBM or I/O device driver domain. Okay, so that would basically avoid a single point of failure. So anyway, there are many benefits with doing this. Now we did a couple of POC, then we got the data. Okay, the data are basically encouraging. As you see, what we did is basically added network backend to HBM and also Zen bus driver. We needed to modify a little bit, then we got the data. I have more the detailed data later, but the bottom line is with the backend in HBM, we got about 25, 28%, roughly 30% performance gain when PV front end talks to the backend. Okay, so we compare the backend in HBM versus backend in PV. Then from PV, front end point of view, it gets a better performance. Okay, and with lower CPU utilization. Okay. Then there are two techniques from copying the data. Namely, they are page flipping or just a copying. Okay, so I have a more analysis on the next one. In case you guys forget about page flipping, because I think in Zen we replaced page flipping with ground copying, I think 3 years ago or something. So anyway, page flipping means you basically change the translation of pages in back end and front end. Okay, so now you don't need to copy. It's kind of magic. You just flip that's the reason it's called page flipping, just to change the translation. But changing translation meaning, even you modify the page table, you still need to, for example, flash TLB. That's kind of costly. And that was the motivation we replaced the page flipping with ground copying years ago. Now, we wondered, things are much simpler in HBM because in HBM, we don't have a complex kind of reference counting. I think we can kind of, work around that kind of page management in PB. In PB, if you are familiar with PBMMU subsystem, there is so-called a page put and a page get, and it can go through many routines. But for HBM, the page or memory management can be much simpler, and we don't need to maintain reference count. Okay. So we thought for HBM, using page flipping can be more efficient. And it turned out it was not so simple, but anyway, we tried, and then this is the data we have. Okay. So with page flipping, these are we added the new hypercore for page flipping, and these are number of, for example, number of hypercores per second, and the TSC cycle per hypercore, and throughput, and the CPU utilization. As you notice, at this point, cannot reach. Anyway, we have slightly better performance throughput with page copying, but CPU utilization is slightly higher. That's what we have today. Of course, that they are much better than PE, so PB backend. In some sense, this is kind of reasonable, but we are looking at why this is happening, because we thought the things are much simpler, but the data is telling the page copying is actually better at this point. Anyway, but anyway, even in that case, we get better performance with backend in HBM with EPT and direct IO BTD. Okay, So this is definitely, I think, worth doing, and we need to think about this kind of configuration in the future. Okay. Now, moving backends actually requires moving device drivers as well, of course, right? Without device driver, just moving backend doesn't make sense. Now, you can think about more extreme case where move all the device driver, physical device driver, to DOM0, basically removing all the device drivers from DOM0, okay? So this is kind of more extreme case, okay? In this case, notice that you basically essentially don't have the native physical device driver in a DOM0, okay? Now you have all the device driver in HBM domain, okay? Now, the benefits, you have some benefits here. First of all, it's probably possible to have a stateless DOM0. And actually, I think at Intel, we did this kind of exercise, I think 2 years ago. And this is a kind of workable solution. So you can have a very small DOM0 without any physical device driver, and use the device driver on HBM domain. Okay. One thing you should notice is that I cannot point here. This is 2. Okay. Too weak, but okay. The BIOS in HBM, okay, says a semi-physical BIOS. That means we need to use the platform BIOS, not the guest BIOS, to do this. The reason is when we boot this, driver domain, we need to use a BIOS code, okay? Since the DOM0 doesn't have a device driver, we need to depend on the BIOS code to copy the data, the image of the HBM. So we needed to use the semi-physical BIOS. The reason I use a semi is for some areas you have to virtualize. But for most part, for example, ACPI and other things, you can use that platform BIOS. What we did was basically copy the BIOS image to memory and use that instance to give when we boot this Linux. Anyway, with this, then all the device drivers are all the native, and you don't need to worry about the device drivers on the DOM0 side, and you get the stateless DOM0, okay? Now, there are some issues with this. Okay, so this shows how we boot DOM0 and the HBM in this context. What we need to do is to create RAM file system, RAM image containing the HBM domain. At the boot time, you have to have a Xen DOM0 and RAM file system image. And once DOM0 is created, the DOM0 mount RAM file system, then where you basically get the image of DOM0, HBM, and then HBM driver just start using a physical device driver and access, for example, the storage and network. Okay, then the system can boot. Okay. Now there are some issues with this. The issue is, first of all, you don't have any NIC in DOM0. That means the DOM0 doesn't have a network capability. So if you do this, you have to use front end in DOM0 and talk to the backend in HBM. Okay, just go back, quickly go back, right? So here you have to have the front end in the DOM0. This is kind of weird. And he needs to talk to this backend even for network and even storage. So again, you don't have a storage on DOM0, and that means that DOM0 doesn't have a persistent. But again, if you have backend in DOM0, you can write the data even from DOM0, and they can be persistent. Okay. So this is kind of an idea, but it's not just idea. We demonstrated this kind of architecture 2 years ago, and if somebody interested in this kind of architecture or setup, I think just I encourage people to do this. I think this is interesting configuration, and probably now, compared with 2 years ago, I think it's more durable, and because we have more hardware stable BIOS. Okay, I think we worked on many issues, for example, BTD issue on BIOS, but they are more stable and available. So anyway, this should be interesting architecture. Okay. So I just want to summarize that my presentation now. So what we did was have to have a backend driver in HBM domain, and as we expected, we got the better performance. For example, in case of a network, we got the about 30% higher throughput with lower CPU utilization. Okay, and the next step is what we want to do is understand what's going on. We thought the page flipping in the EPT should provide better performance, but it turned out the page copy was better. Of course, it had some higher CPU utilization, but so we need to understand what's going on there. And then once we came up with the solution and also other, so come up with solution and optimization, then we're gonna send out the patch. That's the next step. Okay, so anyway, that's I think my presentation, and I'd like to take a question.
I have a couple questions. Earlier on, you mentioned the percentage was 136, 156% of the CPU utilization. I guess this is a simple question. I still haven't gotten my copy. But how do you have a CPU go over 100%?
Oh, that's the total. So you have a back-end side and the front-end side.
Okay, so
Yeah. Yeah.
All right. The next question was, you mentioned that the page copying EPT was outperforming all of those three choices. And you alluded to the part that in PV it's due to a lot of the bookkeeping or grant copying into this data. Have you tried to explore the possibility of doing page copying in PV without any bookkeeping?
No. We just started, so yeah.
I'm just curious. I didn't see it, and I was scratching my head like.
Uh-huh.
You say direct I/O enabled. Is that like a Linux direct I/O, or is this Intel DMA engine? I'm not sure what direct I/O means here.
In terms of technology, it means the same hardware technology. And the direct I/O means assigning, I think, the same as AMD's IOMMU, so direct device assignment.
Okay, all right. So PCI.
Right. Right.
Using
Right.
IOMMU.
Yeah.
Okay, thank you. That was it.
compared with EPT versus PB.
Yeah, I mean, you're running a different Linux, HBM 64-bit Linux with the same device driver in EV 64-bit Linux with the same device driver on Z. What are you comparing exactly?
Well, device driver are different. I mean, also, I don't. It's basically the way, you know. For example, yeah. The kernel, yeah. This one. Okay. So you're saying that the device driver there and this one, right? You know, and
My question is just that when there's a difference in performance, and then there's multiple different variables that are changing.
yeah. So
Which ones are?
if you look at interrupt handling at the cost of, for example, PB versus HBM, if you got, for example, in for example, 64-bit PB, if you got the interrupt in the user mode, then go back to basically the hypervisor, go to the kernel and run device driver, and go back to the user and going back and forth and, you know, flashing a TLB, right? So that's kind of very costly operation. So even though you use the same, you know, the device driver, the interrupt handling is different, and it's tend to be more costly on that PB side.
So, yeah, sorry. I know it's different. I was just wondering, have you yet, maybe you haven't got a chance yet to work out how much of the difference in cost comes from the different aspects? Have you broken down?
That's the, yeah, I mean, okay. We've been just comparing that the EPT side, but yeah, I think we should look at the PB side as well. Yeah. So the answer was we haven't looked at the you know, the PB side yet. Yeah, for PB side, for example, I think Renato did some breakdowns of what happens in the PB. But probably we want to redo with the recent hardware. Question?
Am I correct here that your page flipping is per request in what you're measuring? Are you doing your page flipping is per request? And would that indicate there's potential for an even greater speed up if you did some sort of persistent page matching?
Yeah, it's a per request, yes.
So you've got this kind of strange model where you're not doing much in domain 0 except launching new domains or destroying
Right.
and you've moved all your I/O to the HBM domain. You said, well, that makes domain 0 more reliable. The reliability studies that I'm familiar with long ago maybe say that the vast majority of reliability issues are due to the drivers. So all you've done is shifted the reliability from domain 0 to reliability from another domain. Is that true?
Well, if the DOM 0 fails, then you know, in this today, the entire system fails, and typically the quality of device driver is lower. So by moving those, you know, device driver, kind of unstable, you can say, device driver to some other domain, and then you can improve that the overall, you know, availability and quality.
The key thing then is these are restartable.
Right.